Hello, guys. Welcome to Ramta Solutions and welcome to your grade 10 quantitative as chemical. In fact, this we should be saying grade 10 and grade 11 quantitative aspects of chemical change. Today, we are looking at the empirical formula. So, what is the empirical formula? So, when we look at the empirical formula, remember we have molecular formula. So how different is this empirical formula? Maybe let me add something here. I should say to you, it's different to, oh no, relative. I shouldn't be saying different, but it's related to molecular formula. Okay, it's related to molecular formula. Okay, it's related to molecular formula. So what the empirical formula does or looks like is this. It gives you the simplest ratio of atoms of each element in a substance. I want you to highlight this relative, okay? I want you to highlight this. We're saying relative, okay? We're saying it gives you the simplest ratio, okay? It gives you the simplest ratio of atoms of each element in a substance. So you see, when we say relative or simplest ratio, we are basically saying to you, you're going to relate the number of moles of each atom or of each element in a substance. Okay, we are going to relate the atoms of each element in a substance. Okay, and by so saying, I'm basically saying we're going to relate the number of moles of each element in the substance. So how do we determine empirical formula? It can be determined either when you're given percentage composition or when given a mass composition. So we're going to use, I'm going in fact to give you two examples that shows you how to determine empirical formula when given percentage composition and when given mass composition. So without any waste of time, let's get into it. So now let's say example one. Oh my, example one. Let's say I'm gonna say this. I'm gonna say a compound. Let's write this. A compound contains 52.2% carbon. Let me write that. Contains 52.2% carbon. Remember, carbon has the symbol C. What's going on now? Carbon has the symbol C, okay? And 13%, let me say 13.0% hydrogen. Remember, hydrogen has the symbol H. Hydrogen has the symbol H. And 34.8 oxygen, 34.8% oxygen. If you remember, oxygen has the symbol O. Okay, now determine the empirical formula. Okay, this is your question. Determine the empirical formula. Determine the empirical formula. Okay, determine the empirical formula. So, as you can see, you are given a percentage composition of each element here. So what we can do, our solution first, what we can do, we're going to assume 100 gram of sample. Okay, so you can write the statement. In fact, I write it. Okay, write the statement. Assume 100 grams of sample. It's important. You must always say that when it's given percentages, when you're given percentage element or percentage compositions, you must assume 100 grams of sample. Okay, so when you look at this therefore means the mass of carbon is 52.2% of hydrogen. Let me just do this. 52%, which is 0.522 of 100 grams. What is it? It is 52.2 grams, isn't it? In the same way, 13.0% of hydrogen, or 13.0% of hydrogen is what? 0.13 of 100. So let me not write it like this. Okay, maybe let me be consistent. 0.13 times 100. This tells you that you have 13.0 grams is, what is it? Is hydrogen. And then oxygen. Oxygen was, if you like, you can even say the difference of these guys in 100. Okay. Otherwise, you will say 34.8, 0.348. My mistake. 0.348, 0.348. All right, 0.348 times 100 grams. What is it? It is 34. Oh boy, why do I keep getting these strokes? 34.8 grams. Okay, 34.8 grams. If you add these guys together, you must be getting 100. 2 plus 0 plus 8 is 0. And then, so carry 1. So what is this? 1 plus 2 is 3, 6, 10. Okay, now carried 1. 5 plus 1 plus 3, it's 9 plus that 1, it's 10. Indeed, this is 100 grams. Do you guys see that? This is 100 grams. So indeed, this amounts to 100 grams. Now, we are going to relate the number of moles of these guys. Let's go. So we know number of moles is equal to mass over master. All right? Number of moles is equal to mass over master. Let's remind ourselves. Master carbon was, or is rather, master carbon is, how much is it? Is 12.0 grams. And then master hydrogen, we're gonna call him 1.01 grams. And then master oxygen is 16.0 grams. Oh boy, gram per mole. Remember, we're looking at the molar mass. Okay. So now we need to find the number of moles of each element. So let's begin with carbon. Okay, let's begin with carbon. What is the number of moles of carbon? It is, what is the mass? The mass was 52. Was it 52? Yeah, 52.2 grams. Remember, we're using this formula. Mass is 52.2 grams. All right. Now, what is molar mass of carbon? Molar mass of carbon is 12.0 gram per mole. Now we go to hydrogen. What is the number of mole? It is, hydrogen was, what was the mass? It was 13.0 grams. So this is 13.0 grams over, what is the molar mass of hydrogen? It is 1.01 gram per mole. Now, lastly, look at oxygen. Oxygen, what is the number of moles? Number of moles is mass over molar mass. So what is the mass of oxygen? Let me go back to check. 34.8. So it'll be 34.8 grams over, what is the molar mass? Molar mass is 16.0. 16.0 grams per mole. Okay, now let's get our answers now. Let's get our answers. Oh, answers are, where's my calculator? Answers are, okay, so 52.2 over 12 gives us 4.35. It gives us 4.35 moles, right? It gives us 4.35 moles. Now, 13 divided by 1.01 gives us 12 point, I'm going to write it 12.87, 12.8719. I'm going to round it off to 5 decimal places. It's not going to affect our final answer. Now, 34.8 divided by 16. 34.8 divided by 16 is 2.175 mole. Now, remember guys, I said the definition of empirical formula, or what it does, is that it will give you the simplest ratio of atoms of each element in a substance. Now, a ratio, perfect. Now, remember we have carbon, hydrogen, and oxygen. Check this out. So it'll be carbon, hydrogen, and oxygen. what is the number of moles of carbon? 4.35, 4.35, and that one of hydrogen, 12.87129. So 12.87129. That of oxygen is 2.175. 2.175. All right. So the question that you should ask yourself now is this: which one is the smallest number of moles? It is oxygen. So you must divide everything by 2.175. In other words, you must divide everything by the smallest number of moles. Okay. You must divide everything by the smallest number of moles. So at least you get what is this? So at least you get a whole number. Try to get a whole number. So this is 4.35 divided by 2.175, isn't it? Yes. So what is this? This is 2. Now here we have, what do we have? We have 12.87129 divided by 2.175. What do we have? We have 5.917 blah blah. So this is equivalent to 6, and then obviously this is y. Therefore, empirical formula is C2H6O. As you can see, the subscript here is 1. Yes, this is the 1. The subscript here is H. The subscript here is 2. As you can see, 2 is to 6 is to y. Happy? So this is your empirical formula. Okay, so this example was when you are given, and this example is when you are given percentage compositions. Now let's try example 2. Example 2, I should underline it, given mass composition. Given mass composition. Okay, given mass composition. Okay, so with this one, we are going to say, let's say a 207 gram of, or rather 207 grams of lead. Let me put it like that: 207 grams of lead. 207 grams of lead combines with oxygen. Okay, combines with oxygen to form 239 grams of lead oxide. Or lead oxide. Okay, so determine the empirical formula. Okay, determine the empirical formula. Determine the empirical formula of lead oxide. Okay, of lead oxide. So for our solutions, first thing first, for our solution, I need to highlight one. I need to highlight the molar mass of lead. What is it? It's take 202.7 gram per mole. What is the molar mass of oxygen? Molar mass of oxygen is 16.0 gram per mole. Okay. So now I need you guys to read this question. It says a 207 grams of lead combines with oxygen to form 239 of lead oxide. So here what we are getting, we are getting that lead plus oxygen will give us lead oxide. Right? So we know the mass of lead, let's call him Pb, plus the mass of oxygen, it's gas obviously, and then it will be the mass of this lead oxide. We do not know what it is right now. However, I mean, we do not know its chemical formula, right? Okay. So, but it's PbO something. Okay. So here, what we know, the mass of lead was 207. Okay. And the mass of oxygen, we do not know what it is. The mass of lead oxide was 239. 239. This therefore tells us, or let me use the equal sign because I'm now calculating the masses. So the mass of oxygen, maybe let me say oxygen. So the mass of oxygen is, obviously, it's fine even if I say O2O, will be 32. It'll be 32 grams. Okay. Now note, you have the mass of lead, you also have the mass of oxygen. So now, number of moles, so we know number of moles is equal to mass over molar mass. All right, over molar mass. So now let's go. Now, referring to lead, we have number of moles equals, we said the mass of lead is 207 grams. What is its molar mass? 202.7 gram per mole. 202.7. Okay, 202.7. Okay. 202.7 gram per mole. Now let's refer to oxygen. Oxygen, we just found that it is 32. What is its molar mass? It is 16. All right, it is 16 grams per mole. So what is our answer? This one, obviously, it's 2. This one, it'll be 1 point something, which is 1. So 207.202, also 207 divided by 202.7. Yes, it is 1. Let me write it like this. It's simply 1. It's okay. It's simply 1. Okay. So now, lead, the ratio of lead and oxygen is this. Lead is 1, oxygen is 2. Oh, my mistake. 1 mole and 2 mole. Okay. So now the ratio is 1:2. We have to divide by the lowest, which is 1. So there's no need. We are okay. We can leave it here. Therefore, we can say empirical formula is, all right? We can say empirical formula is what? Is PbO2. I know we could have gotten this directly, right? We could have gotten this directly, but please remember that here the intention is to show you how to calculate empirical formula. Okay, we could have gotten this directly when I was doing this reaction here, right? But now see how we get it when we use empirical formula. So guys, this is empirical formula. How first remember when you are given elemental composition, and then now we just showed you how to get empirical formula when you're given a mass composition. Okay, so this is how you determine your empirical formula. So with that being said, ours ends here. And if you would like to get in touch with us, please visit our website www.aramtasolutions.co.za. On our website, you will see all these icons. If you click on any of them, you will be directed to Facebook, Twitter, X, and Instagram. Okay, and because you're watching this video on YouTube, please like, subscribe, and follow us. Of course, share this video with your friends and classmates. Okay, and if you would like a tutor or anything, you can contact us on WhatsApp or you can email us. You will find these links on our website. All right, guys. So with that being said, we hope you will enjoy this and you will ace these topics. So, bye-bye.